Hello everyone, and welcome today to Your Tech, Your Voice. We are at the home of Reveille. We're at the home of the 12th man, also known as Texas A&M. And with me, I have a great guest, Tim McLaughlin, who is no stranger to the Dell client community. Tim, welcome to the program, and won't you tell us a little bit about what you do here at Texas A&M?
Thank you. I'm happy to be here. So I'm an associate professor. I'm in the Department of Visualization, which is in the College of Architecture. I've been here for about 13 years now.
So your career has really spanned a lot of different things. You've been a draftsman, you've been in Hollywood and worked for film companies like Lucasfilm.
Right.
Then you were brought back here to head up the Department of Visualization. How has technology changed in the multiple industries that you've been a part of?
Well, when I was a draftsman, so this was straight out of my undergrad, I was pen and ink, wearing long white sleeve shirts and a tie, doing pen and ink on vellum, and that was the technology. Now, there was CAD in that system, but I wasn't a CAD operator. When I went back to school, it was because I recognized that computing and design were going to come together, and that's what the visualization program was set up to do.
Interesting. So that industry has seen a convergence with everything being digitized, like a lot of industries have done or either going through, and that happened pretty early on, I guess, in the visualization industry.
So when I was in school as a grad student, Jurassic Park came out. And what was interesting is that there was this recognition that to tell great stories, computer graphics could be used in a photorealistic way. And so by the time I got out with my graduate degree, the doors were open, and that's why I went to Hollywood. I didn't go to Hollywood, I went to Northern California, so the San Francisco Bay Area.
Oh, okay.
Yeah.
So you were telling me that back then the compute was just enormous machines, very expensive. Like what was that like?
Yeah, so my first project was Jumanji, so the Robin Williams Jumanji,
Sure.
the early one. And I worked on a Silicon Graphics machine, SGI.
Oh yeah.
Right, and that box that I was working on was worth more to the company than I was, so it was worth more than my yearly salary, which was I tried not to think about it, you know. I felt like I was valuable to the company and doing the things I was doing. I was working on the deformations and articulation systems, and then eventually dynamic systems for characters. And so having some what we considered at that time great computing horsepower, you know, to look at the graphics, nowhere close to what could be done today. But at that time, we were cutting edge, and that was an exciting place to be. What was different from just a few years earlier is that visual effects had been on the stage with cameras and, you know, what we would call practical visual effects. And all the key creatives were looking at the same problem at the same time. By the time I came in, most of the work was moving to digital. Post-work was digital. And so we were all a team still, but we were all at our individual workstations, and we would get together for dailies, you know, to look at the work that had been done before, take notes, go back, sit by ourselves, you know, use email and other meetings to catch up on what was going on. But it was get together, figure things out, go off on your own, work on your workstation, then get back together and figure things out. And what we were missing was that collaborative atmosphere. So spin forward to today, what's happening is that we can now collaborate again. You know, the real-time computing, what graphics and these computers are allowing is for us to be together in real time working on problems, looking at them collaboratively.
That's really interesting, and you know, right here we got the 7750, and I imagine that's probably 10 times more compute than what you originally worked on back in the SGI days.
Right, yeah.
And you can carry it around with you.
It's amazing.
And get together with people, be on set to look at, hey, how is this going to look? All right, let's see how it looks digitally. Let's see how it looks here.
Right.
That's pretty good stuff.
It is. I just got it a couple of months ago, and I'm really excited about being able to work with it. And heading into the coming fall semester, I'm going to be doing all sorts of crazy things with it.
Nice. Yep. Well, maybe we'll do a follow-up and see how you like it. So what are your students doing once they get their degree and they've graduated from the Department of Visualization? What kind of activities and jobs out there are there for them?
It's a wide range, and it's getting wider. So like I mentioned with the Jurassic Park issue, Toy Story came out right after that, and the Department of Visualization at Texas A&M became a place that was producing technical directors. So people who understand how to do the technology, the programming, put things together in a different way, but also have aesthetic sensibilities. So our students began to be very much media and entertainment oriented, primarily, not only. Now what's changed since then, that industry has grown for sure, but the kinds of computing, the graphics computing, has gone into engineering, architecture, product design, urban planning, simulation for training. It's all over the place now. So our students are moving into different arenas that weren't open just even a few years ago because of how these industries are embracing computer graphics.
Oh, that's interesting. So how many students do you have in the program?
At the graduate level, there are about 65 to 70. At the undergraduate level, there's about 350.
Okay. And we were talking last night about, diversity, especially in IT and STEM and STEAM and those kind of things. And you've got an interesting story with your, breakdown of gender. Talk a little bit about that with us.
So the graduate program is about a 50-50 mix, male-female. And we consider that great because
Yes.
it's a STEM degree. We like to call it STEAM, which is you put the art in the middle of STEM, but it's a STEM degree, and that's a 50-50 is a really good percentage. Now, at the undergraduate level, year to year, it's 2/3, 3/4 female.
That's great.
And that's also a STEM degree, Bachelor of Science in Visualization. So it's kind of unusual, well, very unusual, and something we're not quite sure why it's happening, but we're embracing it and happy for it. So it's great. I'd love to go to SIGGRAPH and see a 50-50 crowd.
Mm-hmm. Yeah, I think that's something in all of IT we're looking at. How can we create that diversity, not just with gender, but really every angle to help us all do better. So with the students and they're working on these programs, what kind of compute do they need to have? What kind of computer are they consuming? And what programs are you teaching them, or are they learning those kind of things?
Right. It's very diverse. So the idea is it's a studio-based education, and so we give them design problems to solve. And we try not to tell them what software they have to use or what computing resources they have to use. So what ideas do they have to come to it? Now, most of them are going to be using some digital content creation packages like Maya, right, or Houdini. And so they're going to be running on machines that are capable of doing good, high quality, sometimes photoreal computer graphics. So, and then when they're getting into real time, those who are interested in games or simulation, getting into things like the Unreal Engine, then that real-time frame rate of high-quality graphics goes up. We try to offer in the department the kinds of computing that's difficult for them to achieve on their own, but that bar keeps changing. We're a public institution, so we're always moving in that direction and trying to provide as much as we can. They're also buying their own laptops and bringing them in, and so that they have a diversity of machines that they use. Some have workstations at home. So it's really a mixed bag, and the goal again is, hey, what is this class about? What is your design thinking about? Okay, let's try to find the computing that is necessary to do that. And it may be a laptop, it may be a tower, it may be some other devices that are plugged in. So it's an interesting collection.
That is interesting. So you were telling me earlier in your office you've got I believe it was a 5820 tower,
right,
and now you've got this 7750 that you're kind of transitioning to. I imagine you use this to teach, your classes, and so it's able to run, all those programs and do everything you need to do, because you never know what the student's going to be using, so you've got to be able to run them all.
Right. Do I want to be ahead of where the students can go, or do I want to be behind? In my thinking, I want to be ahead, but I also don't want to be putting some expectations out there that they can't meet. And I think with this machine, I'm probably out there a little bit, and they'll have to catch up to me, I guess, in this coming year.
There you go. Yeah. Well, it's always good for the teacher to be a little bit ahead.
Yeah, maybe so.
Well, I'm using this Precision 5550, and what's nice about it, it's still a mid-range workstation, but it's right at 4 pounds. Mm-hmm. And you think about some people that might have some limitations on carrying something as big as that. You are still able to do it with something a little bit smaller form factor, and I'm not quite doing all the graphics you're doing, so this works perfect for me. So Tim, this couple of new features on this 7750 you have that I want you to talk about how those could be potentially used is the refresh rate. So one of them is the 120 refresh rate, and then there's also an option to get a 5G radio in it as well. How do you think those could be used?
All right. Well, the refresh rate issue is something that, in terms of frame rate, I'm familiar with from industry backgrounds, but I was always dealing with 24, 30 frames a second, 24 for film, 30 frames a second for video. And so moving into an environment where we're talking about games in real time, moving to 30 to 60 has made a lot of sense. Now, 120 becomes an issue only in certain situations. So does it make sense? Is it useful? It depends. Who's the audience? So who needs it? So if we're making a product, some sort of visualization environment for situations that need fast reaction time. So imagine a training scenario for first responders, military, something like that. Then you get up into the area where that difference between a 60 and a 120 can be a difference in the training effectiveness. So I think it's very appropriate. I'm glad this machine has it, because now we're not limited. We can go there if we need to. And in terms of the 5G side, I love the capacity to take this out in the field, do whatever I need, to be disconnected, to connect other things to it. So I consider this part of an environment of technology where I'm using sensing technology, capture technology. It could be motion capture, it could be image capture. I'm pulling things in, connected to my coworkers so that we can be collaborating from different spaces, and that's all enabled. It's already enabled, now it's enabled where we can handle bigger data, more data faster.
So these workstations now are being used for so many different things that even in enterprise are commercial. There's commercial usage for this as well. You mentioned the training or manufacturing. That might be an area where manufacturing has, let's do virtual training. Let's give you 10, 20 hours in the virtual world.
Right.
Okay, now we're going to put you out there where you can really mess up some equipment, and we want you to be trained up before then.
Right.
So, even, you think these precisions of being more around the marketing or the entertainment, those sort of things, but it's really starting to get in everyday corporate life usage for that. Right.
And in where I find it very engaging in terms of a commercial use, where you're looking at dollars and cents. The computing can be expensive, but when you compare the time to use graphics for the purpose of training, where you can create something I would be interested in is creating, let's say, a photoreal environment for training in a very expensive or dangerous area. Well, let's do that training, like you said, 9 or 10 days in that virtual environment. Make sure everyone's comfortable operating before we move out into the real environment to do the testing and make sure it's all working. That saves time, saves potentially liability, saves from injury, saves on cost of bringing systems down that would be a training scenario system for live and just using them 1 day out of 10, for example.
Yeah, it's great to be able to get some experience in a dangerous situation that's not dangerous, but it feels dangerous because you can be, just so absorbed in it and before you go out and do it. That's really neat, and it's interesting how the IoT side of things, this is another edge device. You can take it on the edge, and with 5G and where that compute and all these data points that are everywhere, 5G plays a key role in that, on bringing that, back to be processed. Some of it's going to be processed here, so it'll be interesting to see what happens in the next 5 or 10 years with 5G.
And this environment that we're in, that we're having this interview, is a studio environment for our students, but it's not a computing-oriented studio. It's a design and making studio, so the computing is part of it. So having workstations like this, having 5G, having students have the capacity to make something that may be useful for mixed reality, augmented reality, plugging in headsets, is all here and possible, and the computing and the networking makes it work.
So you were telling me about a story about an individual. He was here, and then he went off and did some nice things, and the visual graphics design, and now he wants to come back and give back. And I know you're working with some local high schools around here. Tell us about how Dell Technologies and just the ability now to get that compute really almost anywhere, is helping people improve their lives and improve generations to come.
Yeah, it's a story that is probably familiar to most people in the audience, which is that the individuals who tend to go into our field are led there by somebody they know. A door is open to them. And there are a lot of students who don't know somebody that's in the field. They've never seen themselves in that field. And so they have no awareness, let's say that they're watching something in popular media, a movie, The Mandalorian on a TV show, they're playing a video game. They have no sense of idea that, hey, that could be me. I could be making that. So one of my goals, professional goals, is to figure out how to gain that sense of identity, deliver that sense of identity to students when they're at a key decision-making point. So I focus the work on the middle school age, fifth, eighth graders, and I've got a project with a school district up in East Texas, Longview Independent School District, and they're really open to being innovative, trying different things. We're working with Gearbox Software out of Frisco to deliver a curriculum at that level that is a games-oriented curriculum, but it's also bringing into it this idea of identity development, vocational identity development at the adolescent stage before they go into high school, so that they're making the right choices in high school about what courses to take. Hey, I do want to take calculus, I do want to take physics, I do want to take programming, and I want to take theater and art and design so that I'm college ready. Right? We have, as an example, a student that went through our visualization program, and he's at Walt Disney Animation now.
Nice.
And he's from South Texas, Jose Velasquez, we call him Huicho. And his story is that as he was growing up, he never envisioned himself doing that. It just wasn't part of his environment. He came to A&M not knowing exactly what he was going to do as an undergrad, got inspired by the grad program, visualization, got introduced to people that are in the industry, because we have a lot of former students that come back. And he realized, wow, that could be me. I can do that. And so he's really engaged with us in doing outreach and helping us reach students who would otherwise just not even consider it. Eventually, if we're good at this, if we figure it out, then the population in our industries will change, and it'll be more diverse, be more representative of the population as a whole, and then we'll be able to tell more interesting stories as well.
That's great. And the lab that they're using at that school, tell us a little bit more about that.
Yeah, so the school district, Longview School District, Dell set them up with a computing lab in one of their middle schools. The teacher's name is Joe Manns, and he's just thrilled. He's got this beautiful suite of machines. We were up there right at the end of the spring semester and watching the students work, and they're working in Unreal. They're creating games, 3D interactive games, and these are 13, 14-year-olds, 12-year-olds in some cases. And so it's really awesome to see not only the students enthusiastic, but the teacher and the administration of the school district enthusiastic about what it's doing. And they're a STEAM district, they're an international baccalaureate district, so they understand how to pull together this kind of interdisciplinary, merged curricular kind of process, which is what this is about. It's you got to know the science, you got to know the math, you got to know the storytelling, the art, literature. I love that approach.
And learning that base, that student can really take it in many different directions. And you were telling me also that there's a bit of code in there. I think Python is the one that is mostly used, and that is another thing. We need more coders. Right. I mean, the world needs more coders.
Right.
And so if they get introduced that, even if it might be from I want to learn how to program games, you never know where that's going to lead.
Right.
And for them to get exposure at an early age, and to me it's about that I can do this.
Yes.
There is no limitation, and we're not talking about a huge piece of equipment like you started out with that was so expensive it was out of reach. Now they're not, right. And compute is there and available.
Yes, the curriculum that we're working with, Gearbox set up, you use Scratch at the 5th grade level. Now, Scratch you can use, kindergartners can use Scratch, but it's a really easy way to introduce students who may otherwise say, programming, that's not me, that's somebody else, that's not me. Introduce those reluctant students to it and recognize I can create something. We move into being able to program in Python, because Python is in so many DCC packages as a language that can be easily adapted and used. C++, of course, in graphics is where we'd like to get most of the students. So it's I think a wonderful way to allow students to get over that hurdle, which is this barrier of saying, I'm not a programmer, to say, well, programming is just a tool. There's something I want to do, so I'm going to pick up that tool and use it.
Learn all the tools.
Yeah.
And with the compute, I see with your model, you've got a Xeon processor, I got an i7M. That's plenty for people to do that, to compile that code, right there at their desk, wherever they are. If they want to work outside, great. If they want to work inside, that's fine too. It's just, you can do it on the go.
Yeah. Compiling it, in the languages that require it, it is not an issue anymore in most cases that I deal with. You know, some of your audience may differ, but but most issues I deal with, that's not been a problem. And my own experience with programming was not having come from that background. I didn't do it, but a little bit in high school, a little bit in my undergraduate, and then in my graduate school really got into it. But it was when I went to work and I recognized that this is something I'm going to do, that if I have to do it by hand, it's going to take me hours each time I'm going to have to do it. And so I reached out to knowledgeable people around me. They supplied me with a little bit of code. I got excited about making things happen. And from that point, man, there was hardly a problem I picked up that I didn't want to try to code it and figure it out. So it's really a empowering ability once you grasp it.
Yeah, that's great. All right, so let's shift gears a little bit and talk about monitors. So now these monitors are just, the color range that they can do, and in some cases it's even more than what the eye can even, consume. But why is Dell continuing to push that envelope as far as the 4K, the ultra high def, and all those kind of things? We talked a little bit about the 120 hertz as well, but how does that come into play from a visualization perspective? With your students, or what do you think about just the industry as a whole?
Think about from the student's perspective first. Most of the students don't have an awareness of color calibration or even the fidelity of different display devices. And so that education is part of what we want to do. And so what we want to be able to say is, what is your output and who is your audience? Now let's gear the display and color space to that and make them aware of that conversation, aware of the technical issues in it. And so being able to go to a wide range of different color spaces, being able to say, okay, we're going to project this outdoors on a large screen. Okay, that's our target. Now we know we can use the technology and get there. Or we're going to produce something that's only going to be seen on a mobile phone. Okay, let's use the technology in the right color space to do that. So that's where we are with it. Like I was talking about with the refresh rate, is have the range so that you can get where you need to go, but make the choices and have the students understand the choices they have to make so that they don't do more than they have to, and they do what's appropriate for what the output is.
I mean, that's a good lesson. Know your audience. I mean, that can be applied to almost anything. Know who you're talking to, know what device is going to be displayed on, and even though you have power to go past it, you might not need to. That might not be the best answer, especially when you think about, the amount of data that it takes to maybe show a film or something. And if you don't need it to have super high def, if it's going to be shown on a phone, make sure you know that to keep the bits and bytes as low as possible so that, that streaming experience is much better.
Yeah, and as a designer or artist, you never have enough time. Right? You're never done, right? You just have to walk away. And so, for our technical artists, technical directors, we want them to concentrate their time and energy where it's appropriate. So don't waste the time, on creating a product for something that's not going to be seen in a particular way. Use your energy where it's going to be most useful.
If you would like to learn more about the things that we talked about today, I encourage you to go join the Dell Client Community. You can do that at dellclientcommunity.com. Thank you today for watching.
Your tech, your voice.